All right, guys, so we're going to pick up with polynomial behavior, which is going to lead to solving a polynomial inequality. But let's first talk about polynomial behavior. So you can see right here, I'm asking you to determine where this particular quadratic is positive and negative. Well, looking on a coordinate plane, what I'm saying, if I'm asking you when a quadratic is positive and negative, I think you'll agree that above the x-axis is what we consider positive, and then below the x-axis is negative. So what we want to do is take a look at this graph and then see where is it above the x-axis and then where is it below the x-axis. That's going to determine the intervals where this quadratic is positive and negative. Well, how do we graph it? The best way to do it is let's go ahead and factor it and see if we can come up with those x-intercepts. So this is factorable. It factors to x plus 2 times x minus 3. Of course, set that equal to 0. Any questions on factoring, you can go back to my factoring videos. And then what we're going to do is set those factors equal to 0 and solve. So then we subtract 2, so you get x equals negative 2. And of course, we get x is equal to 3. So that means that this quadratic will cross at negative 2, and it crosses at positive 3. And what's the shape going to be? And we can just rough sketch it. We don't have to be completely accurate. What's really important is figuring out where it's crossing the x-axis. So it's roughly going to look something like this. Again, it's not 100%, and it's crossing at 3, but it's close enough. So now what we're interested in is where this is positive. So that is going to be from here to here, and then it's going to be from here to here. Positive because it's above the x-axis. And then if we want to look where it's negative, that is going to be here, which is below the x-axis. So now what we need to do is just go ahead and clarify, specify what those intervals are. Well, let's do a number line chart here. So if I just basically take the x-axis and the key values, well, what are my key values? I got negative 2, because that's where it crosses, and then I have 3, because that's where it crosses over here. Well, all the way to the left is negative infinity, and all the way to the right is positive infinity. All right, so basically this is negative infinity all the way to the left, and that's positive infinity. So as I'm starting out from the left side, all the way negative infinity, and I'm going all the way in to this value, which is negative 2, where is the graph? It is above the x-axis, so that's positive. And then as I go from negative 2 all the way to 3, the graph is below the x-axis, so that would be negative. And then from 3 all the way to infinity, I think you agree the graph is above, so that is positive. So then how do we write out those intervals? So then it is positive, and that is from negative infinity all the way to negative 2. And it's also a positive from 3 to infinity. And then it is negative from negative 2 to 3. We don't have to worry about brackets for this. We're just trying to describe the interval, so parentheses are fine. So that is how we can determine whether a function, or in this case a quadratic, is positive or negative. Now we can use this to help us when we're solving a polynomial inequality. So let's go ahead and take a look at this problem right here. So we want to go ahead and solve this inequality. So what we want to do is definitely get a look at the graph. So in order to do that, we want to go ahead and subtract 12. We want to get set equal to 0 because it's quadratic. And that gives us minus 12 is greater than 0. So now, of course, we want to see if we can factor this, because that would be great. And it does actually factor. It factors to x plus 4 times 2x minus 3. And now what we want to do is set those equal to 0 so we can at least find out where it's crossing the x-axis. So when we do that, now I understand that you have this inequality here, and some students say, well, why don't you set that this as an inequality, not equals to. Again, I'm only doing this piece right here, solving these to get where it crosses the x-axis. We'll take care of the inequality that's going to help us actually find the solutions. So we just solve this, you get x equals -4. And this right here, you add the 3, divide by 2, so you get x is equal to 3/2. So that tells me that this is crossing at -4, and it's crossing at 3/2, which is 1.5. It's going to be roughly right about here. Now, I know this leading coefficient is positive, so I know the quadratic is going to open up. So it's roughly going to look something like this. Again, it's a rough sketch. We're just looking for where it's above the x-axis and where it's below. All right, so now what do we want? That's the key here, is what we're trying to solve this. Well, we want to know when this quadratic is greater than 0. Well, greater than 0 means positive. So we want to know when this quadratic is above the x-axis. I'm not interested when it's below, because I'm trying to solve this inequality, which means when is this greater than 0? So that is when the graph is above the x-axis. So we want those two intervals that are highlighted. Well, remember that we talked about this. All the way on the left side is -infinity. All the way on the right is positive infinity. We can do, again, a number line chart here. So we have -4, 3/2, and it is positive from -infinity all the way to -4, and then it's positive again from 3/2 all the way to infinity. So you can tell here, this is what we want. So these two intervals are what we want. I didn't put the infinity here. For our solution. Now, this is when it's important for the brackets or parentheses. Now, if you notice, the inequality is just greater than. We don't have the bar underneath, which would mean it's also equal to. So we don't want that. We just want it to be greater than, not equal to, so we're going to use parentheses. So our solution for this is going to go from -infinity all the way to -4, parentheses, again, because we're not including that value, union, and then parentheses 3/2, comma, infinity. So this is the actual solution for this inequality. Again, we have parentheses around these two values because we don't have the bar underneath, so it's not equal to. All right, so I'm going to stop the video here, and I'm going to pick up with another problem, but I'm going to do it in a part 2 so this video is not too long.